This is Math 145, Section 1.6, and here we are talking about experiments, specifically experiments. Remember back in 1.2 we looked at observational studies versus experiments? Now we're going to delve deeper into some terminology and ideas strictly talking about experiments. So here we go. You'll remember what set an observational study apart from an experiment was that experiments actually forced the subjects to do one thing versus another, and then they measured the difference in the response variable, as we were calling it. Because we did that, we can show that the explanatory variable actually does cause the change in the response variable. That is the terminology that we were using back in 1.2, and we are going to see some of that terminology again, but we'll see some more as well. So why don't you read over this first few bits there just to familiarize yourself with a little bit more terminology. Pause me down, read it over, and meet me back here. Okay, like I say, there's some more terminology here. Causality, we're talking about does the change in my explanatory variable, maybe it's a dosage in a drug, does that cause a change in my response variable? Perhaps my response variable would be rate of disease, if again I was trying to see if a drug helped that, right? We do have, of course, a little bit of terminology here. The factors are the ways we vary our explanatory variables. Maybe it would be like 20 milligrams of our drug versus 40 milligrams of our drug versus no drug, right? And any combination of the values of factors is called a treatment. So get those ideas in your head. The people, or maybe dogs or cars or whatever we're experimenting on, are experimental units, possibly subjects. And we've seen this idea before as well. A completely randomized design is one in which each experimental unit is randomly assigned to a treatment, which is the, of course, preferred method to do it. So let's look at that experiment. Why don't you read that over and see if you can just answer every one of those questions, and then, like I say, pause me down and start me back up and we'll talk. So these are my answers. Part A asks me what makes this an experiment and not an observational study. And again, going back to really what we talked more about in 1.2, this faculty member assigned students to each treatment. She actually imposed something onto her students. She didn't just observe a traditional class and an online class and compare them, but she assigned students to each treatment, and that is important. B, what are the experimental units? Again, these are just the things that our treatment is applied to. So we're going to say the students in this course. Part C is asking us what is the population for which this study applies. Now, I am going to narrow it down and saying that it's freshman English students. Part D is just trying to get us used to that word treatments. What are the treatments? And again, that definition is up here. And simply you want to say to yourself, well, what are those students being, given as the explanatory variable? And so I'm going to say the traditional course and the online course. So two different treatments. The response variable is how I'm going to figure out if my treatments had any effect. And so I said the test score, and that's talking about the end of the semester test score, which they refer to there at the last sentence. Okay? So again, the idea that we randomly assign people to each treatment, and I shouldn't really say people, but individuals, because we could be talking about rats, we could be talking about cars or whatever. But if we randomly assign these individuals to each treatment, we can say more definitively that the explanatory variable actually did in fact cause any change we saw in the response variable. In this case, with the English students, because we're randomly assigning students to the traditional versus the online course, if there happens to be a difference in the test scores at the end, we can say, yeah, the traditional and the online course difference really did cause that difference in the test scores. Let's get in there with this example. We're going to look at quite a lot more terminology, and you kind of start to see how they write up these kind of studies. And once you read over that paragraph, of course, why don't you try to answer? What are the treatments? Oh, why don't you even do, look at all of those and see what you think. See what you think. Pause me down and start me back up when you're ready. Okay, so we've got this Lipitor drug, which was made by Pfizer. And this big old study was trying to determine the effect of Lipitor on cardiovascular disease, right? And so they took 2,838 people. Notice I do have some nice bold terminology there, and I always try to boldface terminology so you can pick it out easily. So we've got a placebo-controlled double-blind experiment, it tells us. And both of those concepts are going to be talked about down here. So they tell us that the subjects were split roughly in half and randomly assigned either to Lipitor 10 milligrams or a placebo. The subjects were followed for 4 years, and then they counted the number of subjects in each group who experienced a major cardiovascular event, right? And then we got our conclusion that Lipitor did look like it reduced the number of those events and deaths. So, Part A asks, what are the treatments? So I said to myself, well, what things are being imposed? It's either Lipitor 10 milligrams or a placebo. So there's that. Part B gets at this idea of placebo-controlled and what a control group is. Again, notice that terminology there in bold. So Part B says the group that gets the placebo is called the control group. What is a placebo, and why would you want half of the subjects to take a placebo? Now, perhaps you know this already, and perhaps this is new to you. A placebo basically looks and feels just like the drug, but it is not. It's also called a sugar pill sometimes. You might be aware that people sometimes feel better with just about any treatment. Mind over matter, right? And so by giving half of the subjects a sugar pill or a placebo, we minimize the effect that your brain is just going to say, you know what, I got this drug and I am feeling better. If we just gave people Lipitor, we could not distinguish between what the Lipitor was doing and what people's optimistic outlook was doing. Again, this is called the placebo effect. You will see that defined specifically on the last page. Part C says, what's the response variable? Is it qualitative or quantitative? Here we have to be very careful. So for each subject, what are they measuring at the end? For each subject, think about that. And back up there to the paragraph, I know I've got a lot of writing in there, but it says on like the second to last sentence, it says the researchers counted the subjects in each group who experienced a major cardiovascular event. And so for each subject, think about this, for each person, they're asking, did you or did you not have a major cardiovascular event? It's really a yes or no question, right? And if you see it that way, you'll see that that's a category. Yes, I did, or no, I didn't have a cardiovascular. So we're going to say that's a qualitative variable. Even though it sounds like I'm coming up with a number, 83 cardiovascular events, but I'm really asking each subject, did you or did you not have a cardiovascular event? I'm putting them in a category of having had the event or not having had the event. And in Part D, they're asking about the word blind. So again, that terminology up there in the paragraph itself talks about double blind. Down here on Letter D says a blind study is one where the subjects do not know which treatment, Lipitor or placebo, they are receiving. Of course, that is true because you wouldn't want to tell people that you're getting a placebo. Why would we want this? We already really talked about that. So to minimize the placebo effect, so people don't know that they're not getting the drug and their brain can't, somehow miraculously feel better. And then they ask in this part D, what do you think double blind means? Why would we want that? Again, maybe you know already and maybe this is new to you. It happens that double blind means not only do the patients not know what treatment they're getting, but the researchers don't know either. And why we want that is so that the knowledge does not inadvertently affect our conclusion. If your researcher knows who's got the placebo or not, they might let on to the patients, or they simply might use that knowledge, unconsciously or not, in writing up the results. And of course, we don't want that, do we? Okay, so these are the steps of designing an experiment, and unfortunately, we don't really have time or resources to be designing our own experiments this semester. So we're not really going to focus a whole lot on this, but the steps are pretty straightforward, and let's just go through them really quickly. Step 1, of course, you want to identify the problem you want to solve, right? Does Lipitor help with cardiovascular events or not, right? Determine the factors that affect the response variable. Maybe you have to figure out the dosages that you might want to test. 10 milligrams of Lipitor, maybe I want to test 40 milligrams of Lipitor. Maybe I want to test whatever, right? Step 3, determine the number of experimental units. I got to figure out, of course, how many people I'm going to have in my study. I'm going to think about the levels of the explanatory variables, or in the Lipitor one, they determined that they were going to test 10 milligrams of Lipitor versus control. So they're, of course, randomizing those people. And step 5, well, that makes sense. Conduct the experiment. Replication is just this idea that technically the experiment is done on one subject, and replication refers to the fact that you have more than one subject to do it on. And after you collect and process the data, you ask yourself, through a bunch of statistical tools that we're not really talking about here, you ask yourself, did the explanatory variable make a change in the response variable? And how much so? So that is quickie lickety splickety, the 6 steps to designing an experiment. Okay, a little bit more terminology that I wanted to go over a bit. Have the definition of a matched pairs design, and that is just an experimental design in which the experimental units are paired up. The pairs are matched up so that they're somehow related. Okay, and you can think about this as like the same person before and after a treatment. Twins, husband and wives. I might pair up people who are in the same geographical locations so I can compare something that I'm studying, right? Okay, so this little paragraph here is a little on the gruesome side. I tell you, I read about these experiments on twins back when I was like a child, and then when I read this section on matched pairs designs, I remembered, hey, I remember this matched pair design, this gruesome example I remember from World War II Germany. Hey, let me dredge that up. So I looked this up on my favorite source in all of the internet, Wikipedia, and came up with this little summary of that. Go ahead and read that over. That is a good example of a matched pairs design, no matter how gruesome it is. Also, there's 2 other examples of matched pair designs. Go ahead and read those. We've got taste tests. And if you've ever had to take a test at the beginning of a class and then a test at the end of the class, and the teacher was trying to determine if they taught you anything, that is talked about here in that last paragraph. So pause me down, read that over. Okay, so again, we've got all of these lovely examples of matched pairs design. So we've got those poor little babies, those twins in Germany. They were arranged by age and sex, and they would do something to one twin, maybe not do it to the other, and then they could compare them. Decidedly less gruesome. I'm going to give you a Coke and I'm going to give you a Pepsi, and I'm going to ask you which you like best. You are the matched pair. You're not two different people, of course, but you're one person with two different products. And then we've got these pre-tests and post-tests. Comparing the same person before and after teaching gives them more information than if they had given the test to two different people. So that's good to know. All right, we did talk about the placebo effect before, but again, it's just in full out definition here. And I thought this was also very interesting. I found this in the homework. The Hawthorne effect. This isn't really probably going to come up much, but I just thought it was very interesting. It refers to when a person changes their behavior because they know they are being observed. Have you ever done that? I imagine trying to figure out the percentage of people who wash their hands after using a public restroom. And what I'm going to do is I'm going to get myself a clipboard and I'm going to sit on a chair by the sinks in the bathroom. What could possibly go wrong? Okay, that's 1.6. Email me any questions you might have. Have a good one.